Okay, in the dependent samples, we're dealing with our paired data, so it is going to look a little bit differently when we do the null and alternatives. Okay, what we're testing is the difference. So if we subtract our means, this difference is what we're testing, okay? So if our null hypothesis is actually going to be that it's equal to 0, and then the alternative is going to be right-tailed, left-tailed, or two-tailed. The two-tailed would be that it's not equal to 0. Okay? So for the left-tailed, it would be that it's less than 0. Oops, sorry, H1. Oh, or HA I think we're doing, sorry. And the right-tailed would be that it's greater than 0. So remember back when we did confidence intervals, if this one is larger, it's less than 0. If this one is larger, it's greater than 0. Usually what I'll show you in the example here what I have you do to determine if it's right-tailed or left-tailed. Okay? Now the test statistic is a t-test statistic, and they're going to give you the formula for that, but we're actually going to use the calculator for that. We're going to go stat, test, t-test. Now, I'm going to show you an example here. We're not going to do the two sample, we're just going to do it on a t-test. I'll show you how to do that. Critical region method and p-value, we do the same thing, and then our conclusion. Okay, so far? Let's look at an example here. A sports analyst wants to determine if the number of free throws basketball players make in their second year is more than the number of free throws they make in the rookie year. Okay, now this problem I got from Newton is only going to ask you to calculate the test statistic, but there is a problem that'll ask you also to do the null and alternative. That's based on what we're trying to test here. Okay, so step 1 is going to be testing the null and alternative, or I'm sorry, step 1 is going to be writing the null and alternative. Okay, so the way I tell students to do this, okay, if this is going to be my L1, I'm just going to put mu1 above it, and this is going to be my L2, I'm going to put mu2 above it. So let's read the question here. It says, a sports analyst wants to determine if the number of free throws basketball players make in their second year is more than they make in their rookie year. So I want to know if this one is more, right? So remember, your inequality, you point to the smaller one. So if I want to test if this one is more, I'm actually testing if mu1 is less than mu2. And that, whatever, if you write them right beside each other, that is going to be what your alternative is. Exactly what I wrote here. So it'd be mu d is less than 0. And then the null is just that it's equal to 0, or sometimes it actually puts greater than or equal to 0. So either one will work here. Either equal to 0 or greater than or equal to 0. Make sense? So that's a little tricky part on setting up the null and alternative. Okay, now to do the test statistic, we actually going to put it in our calculator. Okay, go ahead and type all this in your calculator and watch, and then I'll show you on the calculator. So we want to make sure first we have the data in our calculator. And I believe we go to stat and edit. I believe I already put it in there. So take some time to put the data in there. L1 and L2. Okay, then what we need to do, I didn't mean to go out there, stay in there. Okay, so for the dependent samples, we're going to do a t-test on the differences, remember. So this is a little bit trickier than just going to do two sample t-tests. We actually have to create this column of differences. So you're going to arrow over and go up to the top so your cursor is over L3 here. And then we're going to tell it to subtract all L1 minus L2. So I want to take 7.41 minus 8.51. But I want it to do it for all of them. So when I'm at the top here, it's kind of like Excel. I'm going to tell it second one, which is L1, minus, you can see down here where it's showing up, second L2. Okay? Sorry about that. And then once we hit enter, you're going to see what happens. It actually subtracts them all. Isn't that cool? Okay, so then we do second quit. And now we go into stat, over to test. Now we're just going to do a regular t-test. We're not going to go to the two sample. This is just a little trickier. Do a t-test. And we're going to make sure we choose data here. And then this is just 0 because we're testing if the difference is greater or less than 0. But the list we're going to test is actually L3. So you want to go into L3 here, leave your frequency as 1. And in this one, because our alternative was less than, we're going to choose less than mu naught. And we go down to calculate. And here's our t-test statistic. And it said to round it to 3 decimal places, so it's negative 4.845. Again, negative 4.845. Now the p-value, in this section, it didn't ask us for the p-value, but of course when you're doing the whole problem, you guys remember to look at this. If it's above 1, you got to look at this over here, this e negative 4, which moving the decimal 4 places to the left brings us to 0.0003. Okay, so our calculator gave us our t-test statistic to be equal to negative 4.845 because it tells us to go to 3 decimal places. I'm going to go ahead and write the p-value here as well as 0.0003. Remember it did that 3.381 and e negative 4. That means you go 1, 2, 3, 4 places. Add the zeros in. Okay? Now, this one just asked us, this particular problem just said find the test statistic in degrees of freedom. So the calculator also told you the degrees of freedom there, which is just n minus 1 or 10. Maybe it didn't tell you, just told you. It told you n. So there's 11 pairs, so we just do that minus 1. So our degrees of freedom is 10. Okay? So we can do the critical region method here. It's a left-tailed test. We're going to go to our t-table, and if it gives us an alpha, let's just pretend alpha is 0.05. We look up our critical region. Okay? Okay? Or if we're doing the p-value approach, we're going to reject H naught if the p-value is less than 0.05. Looking at our p-value here, it is clearly less than 0.05, so our decision is going to be reject H naught. Now when we get to the test, I will let you do either one of these, so if the p-value is easier, go ahead and use that. Unless I tell you specifically to use the critical region. Okay, so at the 5% level of significance, we do or do not have enough statistical evidence. Okay, since we rejected, we do have enough statistical evidence. Remember, we only say we do not have enough statistical evidence if we did not reject. To conclude that, and I got to go back up to the problem here, I was testing. The number of free throws for basketball players made in their second year is more than the number in their rookie year. Number of free throws in their second year is more than in their rookie year. Which makes sense, right? But we have enough statistical evidence to show that now. Okay, so when you're doing one of these on the weekly tests, I'm not sure if I had a dependent one or in the final, you actually do need to show me all 5 steps on these hypothesis testing. I'm not going to actually tell you what they are, so make sure you know what those are, okay?